Hello, hello. Hey, Silverbug, Blurrycat. Hello, hello. Let's have some music, maybe, shall we? I don't know. Maybe no music. Maybe I should just have my music. How do we do this? How do we do this? Let's see. I'm introducing Manim to my language teacher. It's been because no GUI. Why does your language teacher need Manim? Like your programming language teacher? Because otherwise, I mean, I know what's Manim. I'm just, I like it's a somewhat complicated tool if you don't need to do very fancy animations. There's another one that I personally like. Not exactly the same as Manim, but it's the one that I use, human language. Oh, interesting. There's this one that I use for my own stuff, which is motion canvas. I don't know, it's used by this guy, Artificial. He's the creator, and he uses it for his own like YouTube videos. And it's pretty nice. You can see here some kind of GUI, but it's only a viewer GUI. So you edit source code, but then you do but then you can preview what you're doing with a GUI. It's pretty nice. This is TypeScript though, and Canvas. You can export the videos though if you want, and you can also do slideshows. I pretty much like it. Okay, so I'm gonna resume from where I left off this morning. This morning I was doing some work and everything was working except that we were rendering pages that for some freaking reason started with SE comma and we didn't know why. And well, I started printing those lines. And yeah, it turns out that the line is SE comma. It turns out that the first line that we see in Markdown files is SC comma. And you might think, wait, what? Do your Markdown files start with SC comma? Well, about that, check it out. So they don't exactly start with SC comma, but look what's here. Are they Swedish? No, they're not Swedish. So here's what happened. I think I'm basically parsing these files. So this all boils down, by the way, to the fact that my implementation of front matter stuff is subpar, is low quality. But basically what's happening, I think, is that we're basically, while our front matter parsing code should tell us, should leave us here, starting from this line, it actually instead leaves us here, making us think that this is the markdown body, when instead it's this markdown body. And the reason why every file that I was rendering started with had this like random SC in it. Hugo clone, not exactly. Hugo inspired, yes, but very different from Hugo in some aspects. I have a completely different templating language, completely different from front matter language. Even Markdown is different and superior to Hugo. But the overall idea, you have a content folder and you have your layouts. The basics come from Hugo, but there's a lot of like rethinking on top of that basic Hugo idea. So here's what I'm gonna do. Let's look at the page at the code that parses markdown files, because that's where it's busted. Although it's not going to be my code that's busted, I suspect. What I suspect is going to happen is that it's actually something else that's busted. It is curious though that this started only recently, while originally it wasn't like this. So yeah, what happened? I don't know. Page function parse. We go to parse. And to parse, you can see so we think that success contains all the front matter source code. Find Ziggy. And then we return code, which is what we put in success. What? And we parse from code, which is const. What is going on here? How did this code ever work? I feel like I'm going insane. So we have find Ziggy. Find Ziggy. Find Ziggy keeps consuming until it finds dash dash dash, I think. Honestly, this is all garbage. Like I'm not even sure I want to reverse engineer the weird insanity that I was trying to make sense of here. /r. Okay. This whole thing smells bad. But also, what I don't understand is how is it possible that this never gave me any trouble before? And now it's a few bytes short? Is it because I changed the front matter somehow? Not really. That part I didn't really change. That part didn't really exactly change. So what is going on here? Code. Error line. Last len. Why am I setting last len? I'm not even using it anywhere. I think I must have been like high when I wrote this code or something. I don't know. Okay, I want this whole thing to work differently. So I started with this principle where I wanted the front matter to not be part of the markdown format. But that seems a bad idea in hindsight. I mean, I get it to some degree. But what I think we should do is in SuperMD. Okay, let's see. What do we expose from root? AST, node, context value, content directory, max size, range, position, line, span. Choose simple spans if you don't want unwanted new lines in the middle. Yeah. Okay, what I think I want to do here is probably wait, I don't even have front matter in here exposed. SuperMD doesn't have a concept of front matter. Ziggy has a concept of front matter. So that's what's going on. Okay, I get it now. Okay, let's go in AST. Let's change AST because we need this to be better. Const Ziggy. So SuperMD depends on Ziggy now. I don't care. Zon. Yeah, we're already dependent on some kind of Ziggy, so that should not be a huge surprise. Okay, AST. So what we want here is a new init function, basically. So you give me a GPA, you give me a source, but then there might or might not be a front matter, and depending on how that works. So I think it should be like this. Like front matter options. Hmm. So I kind of was hoping to put some stuff in here, but I can't. I was hoping to put the entire front matter in here, but you can't. So I still want options. Something like this, any type. I think I understand what the problem is in any case. Like, even if I squeeze the front matter stuff in here, this doesn't change the fact that I cannot have a CMark markdown parser start from the top. Like, I cannot give it extras. Does this thing understand front matters at all? Does it have a concept of a front matter somewhere in here? If I search for front matter, or like just front and back. So no, not really. 400 comics ahead, 300 comics behind, comments behind, commits behind. CMark. Create funding.yaml. It's a GitHub project. Oh, but they allowed the, I guess, what? Anyway. Okay, so this thing is absolutely not front matter aware. Okay, so squeezing everything in here seems a bad idea after all. Take it out. Take it all back. That's annoying. That is indeed annoying. That is indeed annoying. Okay, let's ignore what we were doing here. Okay, let's take a look at what we do with Ziggy. So front matter has the front matter parser. And this is that piece of garbage. Maybe I broke it because I definitely, like, I edited it. So maybe I broke it in my editing. Although I'm not sure how, but maybe I did. Code, blah, blah, blah. I mean, I did change it, but it's not like I changed much of it. Okay, so here's what I'm thinking. No, okay, I think I get it. So basically, the idea is how much we consumed in here. The problem is we do the parse, but then we should do something more, should we not? Oh, no, I get it. It's because we do consume the original reader. Okay, we consume the original reader, and then we... Oh, snap. Okay, we consume the original reader. That's the side effect that lets us know how many lines we consumed, in a sense. In a sense. Except that we don't have that info anymore, so there's error line. we keep increasing line pointers. Maybe that's also something we should include in success, like how many lines we consumed. So, and that's the actual offset. But that still doesn't explain why we have fewer stuff. Maybe, okay, you know what? Maybe it's page parsing code that is actually dumb. So we do success. This gives us the FMT source. Does it though? Does it actually do that? We do allocate stuff with GPA. Where are we buffering? We're GPA buffering. Holy shit. We're GPA buffering lines. I see. Oh no, so we do this and then we return. What's the success return? We return to own slice sentinel, right? Because the Ziggy isn't even null terminated. Oh my god. Okay, so this is what we return. Which allocator are we passing to this guy here? Passing GPA, okay, so we extra memory that we leak. Okay, so that's kind of dumb. But then this is the source code. FM offset is mem count. Yeah, no, this is definitely not it. Full source is we need to skip fbs.read. Well, not read, like read as in past. Consumed. Pause. Yeah, I guess. Yeah, and then we continue from fbs.pause. Okay, there's a bunch of new stuff. So let's see. Still S fucking E? Come on. Oh, but it's public. Okay, we need to delete public inside simple. So yeah, that's on me. Maybe we should ignore public directories, but anyway. Okay, so here we gave the command. This is correct. This is all correct. This is all correct. That's it. Oh my god. We fixed it. We fixed it. Okay, so this is how this was supposed to work. It wasn't me. I was just doing it wrong. Still not in love with this interface. Okay, I would say it's finally time to work on this. There's more page navigation and stuff that needs to be implemented in Scripty, but Ziggy is in such a shitty state. We need to do better. We need to polish that part of the interface for sure. And you know what? I'm gonna put my music for myself. That's what I'll do. That is what I'll do. Do. Okay. Let's go improve Ziggy. So this is a mess. Like this front matter stuff is a complete mess. Error reporting, absolute crap. There's also no validation. I want a validator interface, and I know what to do with it now. Better error printing. Yes. Okay, so here's our way of doing it. We're going to have a main parser, have a front matter option. We could have it have a front matter option where it searches for these delimiters. Like it treats them as tokens that are part of the document. Hmm. Too many parsers. Okay, how does it work? LSP parser. So we have recovery AST, resilient parser. These are for the LSP. Then we have AST and parse leaky. AST has its own parser. How does this one work? So this one is the one that produces nodes, right? AST is the one that produces nodes. Okay, so parser is what we want to operate on. It has parse leaky code, parse options. My options are, do I want diagnostics? Do I want to copy strings? Which by default is always. Okay. So another one could be front matter. I kind of don't want to make those things generic though. Well, do I need to? Actually, no, I don't need to. Wait, never mind. So the idea then would be like front matter. Is it like a union? Um for Ziggy source. The problem with this, oh man, the problem with this is that if we do this, let's say that we don't find the triple tick. So what do we do? What do we return? What do we return? So if we do allow it, yeah, no, this. Okay, bool found, and then put present, I guess. And then line offset. Lines. Yeah. Yeah, I think that's how it should be. And then this is a pointer. Yeah. Okay, so parser. We pass the options. We try to parse a value. If parser.next returns anything other than EOF, we error out. We say, and then we return an error that says unexpected EOF. Expected EOF. Sure. Okay. Okay, so we're doing not bad. Next thing that we need to do is pass this information down. So I have the parser. Right, this is all driven by the type. So the type drives what we're looking for. Yep. So let's say that we were doing parse struct. Okay. Okay, so here we're immediately saying, so parse struct, this says immediately um, finalize struct, parse this, parse that. Okay. So I think that what we should do is when we start parsing, instead of immediately parsing a value, then we need to ask ourselves, oh, we also may need to clarify this. These allow the presence of external content. Allow optionally the presence of external content. No, that's not exactly like this. This is like allow optionally presence. This is something more like, hey, X2. Okay, we are not saying that there might or may not, we're parsing a Ziggy file and there might not be external content. No, it's different. We are parsing external content. The question is there Ziggy in there or not? These allow. I think it's disallow require. and there's no present. This is more like, is front matter? Yeah, that's actually the question. The question is what we're parsing a front matter document? Is front matter? Doesn't even need to be a union at this point. It could be a boolean. The problem is that we do want the in out parameter. So front matter. It's like, is this Ziggy data embedded in an external document, or is it a pure Ziggy file? Pure embedded, I guess. That's kind of the idea. Optional front matter meta. That is a fair point. Yeah. Hey, Rocket Ranger. Did I get a new keyboard? Not exactly. Okay, let's do it. Let's express this like this. Set to null when parsing a pure Ziggy file. Set to null when parsing a pure Ziggy file. Provide it yeah, it's a sound emulator. I installed it, I don't know, like yesterday or something. I'm just messing with it. So when the value is provided, let's put it that way. So using the advantage 360. Oh yeah. Okay. This is so nice because this allows us to express these front matter errors as Ziggy errors that we can then put inside of diagnostic if we want. Actually, you know what? This last part doesn't even matter. Okay, so parse leaky. The idea is instead of doing parse value right away, we do if so if we have it from matter meta, then we expect to find a dash dash dash. How do we do this? So what I was thinking originally is that we make the parser return us that as a value, or the tokenizer return to us that as a value. Maybe. But maybe no, we don't even need to do that. Although, I mean, we kind of want to advance the tokenizer because otherwise the tokenizer, yeah, we do want to advance the tokenizer because otherwise the tokenizer doesn't know where to start. So let's add a new token. Invalid.common. Front matter frame. Just call it front matter, I guess. Okay. So like seem. So the idea is if we are in state start, then we might find that. So we are in state start and we find all of these things. If it's a dash, we think it's a number. Oh, that's interesting. Well, about that. Now this has to become more complicated. If it's a dash, we need to look ahead a little bit more. Can we look ahead a little bit more? We have EDX. Okay. We're always doing +1. Okay, I guess we can do this. We can do if std mem.starts with code starting at self.idx dot. Rest.tag front matter rest.lock.end equals self.idx. We need to increase self.idx. Then we break. If it's not, then we just do state equals dot number. So we just do a little bit of look ahead. 2 extra characters. Perfect. Wait, let me think for a second. If IDX was 0, index 0 is a 1. Oh, we're only doing +2. So this adds how much it consumes actually. That's interesting. This adds how much it consumes because it breaks. I think the break doesn't make this thing run. So we need to add how much we consume every time we do this, I think. This means 3. This seems to be the case of what we do. Okay. Okay, perfect. So this this front matter token is not allowed normally. Nobody wants it, I think, except us in parser when we set that thing to something. So we do we get the token, I guess. Get a token. And if the tag is different than front matter, then that's the problem. There's also another problem with this. So I mentioned that we would write down how many lines, but I don't think we know how to do this because the tokenizer skips lines like crazy. Although we could make it accumulated. Every time it encounters a new line, we increase that number. I mean, it is going forward line by line, so why not? Okay, let's assume the tokenizer can do that. So we return error.no front matter or error.front matter. Missing front matter. Missing front matter. Okay. And then we look at extra. And again, this depends on the FM stuff. Also, here, I don't think I need to write down anything. It's down here where we want to do this. Front master missing. Or you know what? Missing front matter and open front matter. Okay, so now we need to write down inside FM. We also expect a new line. So I think the token should also contain a new line. Oh man, how do we do this? At least for the end one. I guess we want to consume a new line, basically, and then do +1. Yeah. Or IDX, I don't remember. Yeah, kinda. Kinda like that. Okay, let's make this better now. Okay, Tokenizer doesn't keep track of lines. Let's make it do that. Okay, there might be some shortcuts that we take in here that might make this a problem. Let's see. AZ, 3 lines, string, identifier, that's fine. Number, that's fine. String. In a string, if we see a new line, tag invalid. Honestly, the fact that we don't update the counting here is okay because we don't care about cases where we do not generate invalid things. So that's fine. Line string. Look at that bad boy. Comment start. We have finish comment. Interesting. Comment. If you want comments. Oh, like we ignore them. Okay, so we ignore comments in that case, but either case we do count lines. It doesn't matter. What does finish comment do? If mem starts with this, tag is stop comment line. Okay, I think this should be fine. What is this big else? Switch state. It's an else inside the switching state. It's an else for the while. If we didn't break from the while, finish identifier, finish number. I'm not sure I'm following, but hopefully what I did is fine. Okay, so the tokenizer is counting lines, ideally. Test case, we have an input and we have expected. expect equal. Do we not defer? We should also expect this thing to um hmm. They really never do anything better than this. Like there's nothing more after that. That's an EOF, for example. Oh, what am I doing? I think I can do equal. I need to do expect. Hey, is there no count scalar? Okay. Okay, let's see how we're doing. Okay, we're missing front matter meta around a bunch. Oh, I didn't give it a default value, did I? All right, it should have made it better. Number of function expected, one argument, found 0. Fair. Incompatible types, token, and enum literal. Oh, come on. Really? Oh, it's because dot tile, of course. Expected type overflow memory syntax, missing front matter. So we have missing front matter and open front matter. There are new errors that we put in here. Could be bad front matter, but it's fine. Default value equals null. Let's see. No field name default value in struct type start field. That's That's a Zig update thing. This is the default value PTR, I think. 2 failed, 1 skipped, 19 leaked. Okay, cool. Memory leaked, memory leaked, memory leaked. Oh my god, why are we leaking so much? Jesus Christ. Yeah, okay, I get it. Let's try to not leak, huh? Where are we leaking? In Ziggy parser, we're returning to own slice, then never gets freed, but where would we start from? No, dude, there. Okay, test multi-line string. There we go. 917. Okay, we call parse leaky. Yeah, we do call parse leaky, don't we? We do indeed call parse leaky, don't we? Okay. What am I doing? Arena. You know what? Here's what I'm gonna do. Okay. Now we have only failed tests. Expected 5 found 3. We don't agree on the number of lines. Comments are skipped. Multi-line string. Oh, that's good. Let's see multi-line string. It is inside Tokenizer. Oh, we actually had it there. There we go. So what do we expect to find? 1, 2, 3. Right? Maybe 4? Expected 5. Found 3. I guess the first one is what is expected. And the second one is where we 1, 2, 3. Now, okay, so this string here contains 3 new lines. Yes. So 3 is the right number. I think I'm flipping them around here. Okay. How the heck are we getting to count to 5? What? I'm somehow counting the same new line multiple times. I don't get it. Pull forward the start. Loop again. This doesn't even matter because we're not even exercising this. What the heck is going on? Oh shit, we segfault even? What? What? We segfault? That's a watch thing. No, we freaking segfault. What? Ah, god damn it. Does the tokenizer have any particular interesting import? Oh no, look, the tokenizer doesn't depend on anything. That's delightful. So it means that we can test it directly. Process key exited with status 1. Where's my segfault though? So it means that it's not tokenizer that segfaults. It's some other thing somewhere else that segfaults. Yeah, that explains it. Maybe. While executing parser test struct missing bottom curly, the following command terminated with signal 6. Maybe this is it. Okay. I guess we want to fix these number counts first. Expected 8, found 12. Jesus. Okay, here's what I would do. In this test, I guess you can std debug.print the count to do every time we loop, before and after, or maybe just after. Let's see. The name test of while executing has never been the failing test. So that's why on GDB. Yeah, I guess we'll see. Let me fix the count stuff first. Let's do it without LDB. So, okay, there's a problem because we don't print anything that makes us start this thing. But okay, let's assume that we start from 0 and then 2 and then 4 and then 5, 5. Like, what the heck? Every time we make a new tokenizer, we loop. Let's add another print up here. Okay. Dot 0, str 0, equal sign 0. That's not 2, that's 1. How do you get to 2? That's 1, man, not 2. That's another 1, not 2. It's another 1. And it's 1 also for this guy. What? What am I missing? Oh, you know what? I guess I'm counting. Oh, right. You know what? I think I understand what's going on. I think in start state, I see a new line here. Okay, you know what my mistake is, I think? Trying to sneak this thing into various things, when in reality, it's more like this. Honestly, I don't care which state I'm in. If I see a new line, that's a new line. So everything else is back to normal. Let's see. Still going crazy. Oh, shit. I think I know why. It's because I'm doing something like look ahead. God damn this language. I'm doing look ahead. So because I'm doing look ahead, I bet you that somewhere in the parser code we're doing some stupid fucking look ahead. That's what's going on. That is what's going on. We probably have a name for it. Let's see what we got. Yeah, look at fucking peak. Well, you know how it is. Not using the fair. This is still not the solution though, because it still seems that we are overcounting. Test expected equal. So why are we still not making any progress here? I'm surprised. So wait. Let me add a panic maybe. We don't even hit the panic. Okay, so this is something that we needed to do, but that's not the full solution still. Crazy. What else am I supposed to do? I print lines. Is there like some super ass version of look ahead that I'm doing without even losing peak? No, but even if I did, I would restore the full state of the tokenizer. Maybe. You know what? Let's take a look at parser. Next. Oh, look, we have our own peak in here where we copy the tokenizer. We make a copy of the tokenizer and then we call next on the copy. But still. Okay. Out of curiosity. Okay, so this is the only place where we call +1. Breakpoint time. Oh, it crashed. I hate tests. Now it's gonna complain. I'm using the testing allocator. I'm guessing. Run, and then what happened? So please don't exact. Can I follow, please? There we go. So okay. At index 6, we find a new line. 0, 1, 2, 3, 4, 5, 6. Indeed, we find one new line at 6. Continue. This time we're at index 14. Lines count is 1. Okay, 14. This was 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. Why are we still at 14? Why did we loop again? You son of a bitch. Why did we loop again? Why are we back here? Because it's a comment. Sorry, it's a multi-line string case. It's the multi-line string case. Search for self-line plus one. No, this is the only self-lines plus one. There's nowhere else anymore. The problem is that we saw a new line and then we found a like string continuation basically because we changed state. So we changed state. We changed state where because of this line string start. This moves us to line string. Here we do nothing. No, that still doesn't fully explain it to me. Why are we still at index 14 with lines set to 2? Why hasn't self.idx increased? Let's restart, and once we hit 14, can I restart? Once we hit 14, we start stepping. Hit an exec, continue. Okay. Index 14. Okay, let's start stepping now. So we switch state. We enter the case line string. Let's print the index. Index is still 14. Why are we entering line string with index still at 14? Why are we entering line string without increasing index? Oh, yeah, we are not increasing index, that's for sure. Basically, we're saying, yeah, we saw a new line the first time. We move forward the starting location of our thing. Then we loop again? No, I'm still not fully sold on this fact that what's at 14? Because I was thinking that at 14 we had the new line, but maybe we don't. Maybe 14 we have the slash, which is what moves us here. So line string start, I guess that explains why we're here and why we loop again. But still, self.idx should have increased, shouldn't it? I 178. Is there anywhere in the code that you're decrementing IDX? I don't think so. No, I don't think I am. I'm increasing it, I'm moving forward, but I'm never subtracting to it. If only I could print index 14 of a string, right? Let's try fr v code at 14, please. You code.ptr at 14. It's a new line. Okay. 15 is a space. 16 is a space. 17 is where we have the slash. So it is correct to say that at index 14 is the new line. How do we go to line string? Also, you know what? Debug information in Ziggy is also kind of glitchy sometimes. I'm not decrementing IDX. In comment, are you decrementing IDX? I'm not. Look. Oh, I am. Fuck, you're right. Oh, yes. Here I'm not. That explains it, huh? So I'm basically not counting this new line. So we get in here. I see the new line. I don't consume it because I don't want to include it. Okay, I guess the idea is that I don't want to include a new line. So maybe that's why a continuation starts with a new line. Okay, I get it. I guess we do also self dot. So if well, actually, I don't think I even need the if. Nah. Okay. Test command crashed. Lines 0, 0, 0, 0. No, I want the run version. Terminated by Zig drop. How many times are we going back and forth with this stuff? Oh yeah, you're right. I left the breakpoint in. Right. No, that should not be subtracting because they should be balanced. Like there is no way that deletes a new line that we haven't added at top. Or if it does, it's still broken. We still do the thing. What? Even slashes. Okay, so no, these are all the uses of minus that we have anywhere in the code. Okay, let's continue with the debugging stuff though. Index 6. You know what? Let's just continue. Sorry, let's just step also from here. We switch state, switching character C. We get into this state. Then we hit a break. No, I think that break is fake. We loop. We end the while. We loop again. We increase IDX. Man, this debug info is so fucking jank. In any case, now IDX is 7. It seems like we are evaluating in the plus, but we're still at 7. And there's no new line at 7. There's way too much jank. Fuck it, let's continue. Okay. Index 14. Line set to 1. Next. It seems that we're switching on the state line string, are we? We are, for real. How did it happen though? Because we were at 14, which is a new line. This moves stuff forward. So IDX at this point has to be, it cannot be 14. It has to be more. So I think that we're getting bad debug info. And the reality is that we went forward from 14 to 15, 16, 17 until we found this guy that moved us to line string start. And line string start then moved us to line string. No. This is saying that rest lock end is 14. Then when we're returning the token, we're returning the token. Okay, let me think for a moment because maybe I'm just not thinking about the situation correctly enough. No, okay, you know what? Wait, this is fair. So at 14, there's one thing that's true. At 14, we don't want to return right away. At 14, we want to continue looping until we consume all the lines. That's definitely for sure. You know what's happening at 14? At 14, we are in a different state. That's what I was missing. If I run this, I do frv self.state. Is it just state? It's not itself. Yeah. Set is start. Then I do continue. And set is not start. State is line string. That's why we enter line string. Okay. So we are in line string already. The state is line string. We don't enter in here. Line string. That's our state. We see a new line. Oh, we're returning as a token? No. We don't return anything. Well, we do break though. So we break the while. Well, but breaking the while makes us return token. Okay, this is kind of weird because so state is local of next. We know that we don't want to. That is break line string. Is this really break? State is start. Wait a second. Start is 9. End is unset. That's correct. So that's correct. The thing that I just do not understand is how are we not increasing these? Because we enter a new line in this case. The idea is we entered a new line originally. Then at some point we encountered a slash, which got us in line string start. In line string start, we found a second slash, which got us in line string. In line string, we will find a bunch of which got us in line string, and we also loop every time. So in line string, we keep consuming until we find either an EOF or a new line. Either an EOF or a new line. At which point we write down self.idx. But which basically means that we are not including the new line. This is wrong though. This is wrong because line string, is this parsing just completely busted? I think the new line, the multi-line parsing is just completely busted somehow. No, it's not exactly completely busted. Like, no, okay, I get it. It means that we return multi-line things one line at a time. Right. So we return it one line at a time. Yeah, I think the problem is just that we need to increase IDX. And it was harmless before, but not doing it now, it's causing us to have trouble. I think this is it then. Oh, fucking Zig trap. Yes. There we go. Oh, there you go. Expected 3, found 4. So we got something similar, I guess, with other stuff. I see comments. Maybe comments have the same problem. Let's take a look. The comments have the same exact problem. Line string start, line string, comment start, comment. If one comments, there's finish comment and then break. Finish comment. We do not increase here. Else, if we did not want a comment, I see why we're decreasing this. We're decreasing this because we are decreasing this because we will increase it at the end of the loop because we continue the loop. But at the same time, why are we doing this? If I find a comment and I don't want to capture it, bye Silverbug, have a good night. So if we find a full comment which ends with a new line, but we don't want to keep comments and want to skip it, that's fine. Location start is self.idx. Oh, you know why we might be decreasing this in the event of an EOF? Because we don't want to get past the EOF. That's why I think we're doing this. So this should be more like this. I think that's how this should be. Let's see. Okay, generally speaking, we still have a bunch of tests that pass, one that fails, and a crash somehow, somewhere. There's a seg fault, which I don't understand where that comes from. So, I don't know. So now we have, starting for /invalid. Oh, for invalid, the count doesn't match. I mean, yeah, sure. So I was saying I wasn't bothering in the case of invalid stuff, but maybe we should do it. I think it was here. Although, did we get ourselves in string? I don't think we got ourselves in string. I think it was somewhere else. Like 1. You see this 1 and then 2 right away? That's sus. Because it should be 0. And that's the invalid thing. Then 1, because it finds this new line. And then these guys. But I think this invalid token is looking at the new line twice. Start, identifier, number string, blah, 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 comment. Honestly, I don't care about that one. So how does it work? We saw as a character that we don't like, which is here, comment start. This got us into comment start. Comment start. We're looking for a comment, but this fails. So we say idx +1 tag invalid. So that's this. And then we see letters. What do we think that the letters are? An identifier. Oh, I see. We're thinking that we're looking at an identifier. Else finish identifier. And is self.idx. If it's true, false, null, we do magic. Otherwise, we don't do anything. And then we break. Well, probably want to do this. Also this. Oh no, we broke 4 tests. Expected comma, found dot. So never mind. I mean, we do break true. Oh, no, I actually don't know. Why is that a problem? Expected Ziggy token invalid. Found Ziggy tokenizer tag right square bracket. Okay, I see. I guess what we would need here is technically. Okay, what we would need here is technically. Did you see a new line? If you saw a new line, then move forward. Man, the reality is just that in reality, we just do not care about counting. You know what? Here's how we fix it. I really don't care about keeping the counts right when a token is invalid. So here's how we do it. Success is true. And then we say if e.tag invalid, we set success to false. And we only do this test if there was no invalid tag. I really do not care about having that count happen correctly with invalid tokens in the mix. Oh, that's already a tag. Okay. Okay, so we're back to segfaulting somehow in missing bottom curly. But I can't just run this, can I? Oh no, I can. Let's fucking go. Array list, we're freeing something. Oh, we're doing something funky with memory. That's what's going on. Missing bottom curly, huh? Let's see what we're doing. Okay, test case. Case, blah, 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 blah. Yeah, missing bottom curly. Diagnostic path equals null. Oh, shit. Yeah. Actually, we don't need to the init, basically. That's what's causing the crash. There might be other tests that have the same problem. Yeah. Invalid free. Testing allocator free. Oh, god damn, we have more of these. 814. Oh, so we did free stuff in here. We didn't need the... but we were doing parse leaky. Well, I guess we knew that we were never copying stuff, maybe? Three leaked. God damn it. What are we doing wrong in here? Case, path, diagnostic, parse options, heap, arena allocator, init, parse leaky. Oh shit, schema. Oh man. So this makes an AST using testing allocator. What's the problem though now? Oh, there's also only one. Wait, what? So this is a leak. Schema init. So this guy does leak, huh? Literal values. That's annoying. Why are we leaking? So it seems that it's schema that leaks, but in theory, schema should not leak, should it? What you got in here? Root is a rule. Okay. So you have code that you don't own. So you shouldn't even have it. You have nodes, and then you have literals and struct, which are string, array, hash map, unmanaged. Okay. And where is the string? Docstring? Oh no. We're allocating, aren't we? Oh shit. The docstring allocates. Does it allocate every single time? No. Well, okay. Oh my god. Empty string doesn't allocate. Does everything else always allocate? It does. Okay, so we have docstring on hover. This is an element inside of literals. Hover. I think I might even be able to skip that because I think the allocator checks for that. Yeah. Still leaking. What? Oh, snippet string. God damn it, dude. Really? Right. Oh no, where's snippet placed? Struct rule field help snippet. So it's not here. So every field has help snippet. Jesus. What was it? Field help snippet. Still not quite there yet, huh? Doc. I think doc was the other thing next to snippet. Yeah. So never mind, we want those. Maybe submarines need to manage the data. Well, no. I mean, if you want to have that, you can do that. But if there's a way of tracking allocations individually and having the thing have a correct init, you want to have a correct init. Then the user can provide an arena and not use the init if they want to. But But if your thing should work with a normal allocator, you should try to make it work with a normal allocator, and you should have a function in the init. For example, you saw that the other Ziggy parsings had parse leaky, because for certain types you can only parse things in a leaky manner. There is no, well, there is no easy way of not doing that. There are ways, but not easy. So yeah, let's see, what are we doing here? So what else is here? Parse bytes, an escape tokenizer. We are parse value. Okay, so we're done. We're done with those tests. We're now back to tokenizer calls parse alloc on something. Where does this start from? In the dynamic. Oh shit. So dynamic has the problem. I wish I had a little bit more, because I would then be able to see more stuff. Can I do this? Oh, I can do this, but it's not a real, like it prints the stack trace, but it's not a real panic. It's unfortunate. So I would need to configure the thing to keep track of more frames. Okay, too much meta stupid programming in here. But the fact that we're in dynamic, it means that it's a test that's testing dynamic. So probably it's in dynamic. So in dynamic, we're leaking from dynamic, which makes sense. How many tests we have? We don't even have that many tests. And would you look at that? We have parse leaky plus the testing allocator, huh? God fucking damn it. But parse leaky tells you that it's leaky, so you do need an arena in this case. So let's go back to parser temporarily. Yoink these lines. Yoink these lines. Hey, Garitham, you hear a new keyboard? So what do we have here? Oh, here we have like stringify options. But we also parse, don't we? I think we round trip this thing. Output.dinit. Do we not parse? You know what? Maybe this actually is sufficient. Let's look at the other ones. Is it a mechanical keyboard? Interesting questions. Have you changed? It's actually a virtual keyboard thing. Like you hear the sound, but it's generated by software. Okay, let's see if we leak less now. Invalid free. Right. One of the ones where we put our arena stuff still has some freeze using the other thing. Where is it? Where is it? This should be fine. Is this one? Oh yeah, look at this. You naughty boy. Well, if you guys like it, yeah, I like it too. There we go. Okay, we're stuck with just the debug print from Tokenizer. Oof, what an adventure. So we we now have back to a passing test suite. Holy cow. It took us for freaking ever, and we haven't even tested the new stuff yet. So let's test the new stuff. Let's start with the tokenizer. Tokenizer, I guess what we want to do is front matter. We want to pass another one that says true for the front matter stuff. So we want to change this to true, comma, false. Okay. So what do we want to test here? Front matter, right? So give me a simple one. Comments are skipped. Basics. Give me a basics one, but with dash dash dash. 1, 2, 3, 4. Okay, we want this to report 5. I don't think I've implemented the stuff that reports 5, so we should get a line mismatch. So tokenizer. I'm an idiot. We don't need an extra parameter. We just need. I'm a complete fucking idiot. Yeah. Front matter. Like this. 1, 2, 3, 4. You know what? It's fine if it reports 4. And then the way it works is that we want. It's this same thing. Can I put like a new line in here and have some nice. No. Would be nice if we could, though. Can I do this? No. Okay. So what we want is not front matter, comma EOF, well, and then EOF. Okay, let's see. Do we pass this test? Oh, I'm a double idiot because I copied one thing but didn't copy the other. God damn it. Okay. God damn it. Okay, let's see. Let's go. Okay, so perfect. Next is testing the parser. This is the other guy that can deal with these things. So give me basics, and then I'll make basically a better basics one, I guess. Struct duplicate field. Okay, you know what? I'm gonna copy these. Just make it better. Front matter. Okay. So what do we want here? We want parse options. From matter meta, set to undefined. Then we have all the arena invocation. Then we have parse leaky. We expect an error, but I don't want that anymore. I want that to be like this. So I don't expect an error. Expect a success. I'm gonna try this. No expect FMT. What I expect is, I guess, FM to contain the correct data. std dot wait, what was I saying? I expect lines to be the correct value. Yeah, the FM stuff, right? So testing, expect. And I need to do the line splitting. Let's go in Tokenizer. Test case, how do we split? There you go. And I don't really care about the result. No filling front matter struct in parse options. Are you sure? Did I use an uppercase M? Oh, it's front matter meta. Error union is ignored. Failed. Why? Wait, one failed, one skipped. What happened? What does failed mean? Return Zig error, add error, must any talk. Parse struct, parse value, parse leaky. While executing test schema AST test basics. What? Wait, what? Okay, give me LDB. I'm not sure I understand. I just exited. God damn it, dude. Why do you exit? Why do you exit instead of panicking? So what is the problem here? Okay, Ziggy will test. Ziggy parser test front matter failed. Fails inside diagnostic. What does that even mean? Returning a Zig error. It means... Oh, shit. Wait, no. Okay, it means that parse leaky fails. Why does parse leaky fail? Should it? Foo bar and then case. Oh, I think I get what the problem is. The problem is we obtain... Okay, we don't know if the struct is done or not at any point. Like, we are parsing fields, but there might be more, and we don't know yet. We need to consume them all. That's what we know. But we hit um, a front matter. And because we hit a front matter token, we return early. This only works if we are the top level thing. So what I think we should do is we need this in a top level. This can only happen in a top level struct of this kind. Okay, as a test, if I do this, I expect that now I pass the test, or I don't fail it the same way. Error open front matter. Okay, we failed it in a different manner. That surprises me though. A bit. But okay, so that's the other problem. But then we need to have special handling for the front matter case for top level structs that have no curlies. Open front matter. Why do we claim that there is an open front matter here? What token do we get? I guess we want to... just the entire token, I guess. I bet you that we don't consume the closing curly or something. What happens? Bet token, Ziggy EOF. EOF. Why do we consume the last front matter? Why do we consume the last front matter token and we don't even complain about it? What is happening in parse value? What happens inside parse value? Parser come time first token. Parser done next. Oh, that calls Tokenizer done next. Oh, that's so funny. Okay. So we call parser done next. That makes us call parse value. It's a struct called parse struct. When a top level struct omits curlies, the first token will be a dot. In such case, we don't want to expect a closing right bracket. Right. Field scene. If need closing right bracket. We're looking for either a dot or a right bracket. Right. The problem is that this is incompatible with our thing. Parse track returns only this stuff. I think that, how do we do this? Parse track needs an extra parameter to let us know if it parsed a no, you know what? We consider a front matter as a terminal token, just like EOF, basically. Front matter is also an EOF. And if it's different than dot, we call finalize struct. That's interesting. We call finalize struct which does final validation. Okay. Struct end. Where do you use struct end? Oh, this is where the struct ended. We say get selection. Missing field. Okay. And then we return the value. So this means okay, with this, we need to be able to consume the front matter token. So that's what we do. That happens. Okay, that's correct. I think a front matter token anywhere else is a problem. But then at the top level, how do we do this? I guess we basically try to do next. Hey, Medlingo, thank you for the $15 to the ZSF. Thank you very much. So I guess when we return, we try to do next. And if it's a front matter token, great. And if it's not, we don't do anything. But then we might potentially consume multiple front matter tokens. That is a problem, I would say. So here's also what I would do then. I would try finalize struct, and then I would say if talk.tag, if it's a front matter, then there needs to be some parameter that we pass around that says consumed ending front matter. Actually, we have self, right? So it's just something that we put inside self. Yeah, like we say, yeah, we close the front matter, and then we return. Front matter is only allowed if we do not need a closing right bracket, which is only true for top level stuff. So then we need just to add this stuff to parser. Oh, right. Which is up here. Oh, the parser has a state. Start left bracket or comma, field dot. Interesting. Close from matter starts at false. And say if front matter meta so we need to do next token. Oh, here's how we do it. Close front matter is an optional token. Which we might very well make a token and say, no, whatever. Okay, it's an optional token. And we put the token there. And then in here we say, well, token is parser dot closed front matter, or else this guy. And if it's not a front matter token, we complain that it's an open front matter. Otherwise, we do parser, tokenizer lines, offset parser, tokenizer IDX. Okay, cool. Ziggy test. So this should be better. Random question, but why are those objects not const/var? Does the compiler just handle it? Which objects? You mean these things? Is this? Okay, what you're looking at, JR, this is a top level struct definition. So in Zig, files are structs implicitly. And what I'm doing here is defining fields inside of a struct definition that's it's like at the top level. Like in normal syntax, you would do something like this. You would do something like this. But this entire file is the parser struct. So I'm specifying its fields at the top level. So they are not variables because they are fields inside of a parser struct. So whenever you import parser, instead of doing import parser dot parser, you can import parser directly, and that's your struct definition. That's the type. And so you instantiate that. And that's because you have parser? No, it's because I have these things at the top level. The fact that I have this allows me to refer to the type defined at the top level as parser. But I could take this out and use this everywhere, and it would also work. So like this is for convenience, not for necessity. This is what makes this whole thing work. Okay, what's the problem now? Member function expected 0 arguments found 1. Oh, I changed this next stuff to parser, and now it doesn't want an argument anymore, huh? Yeah, it's a peculiarity of Zig. Other languages don't have that. Okay, so we have made things a little bit better, but not fully. So that makes sense because I added code for this case, which is not the one that I'm testing for. So let's try the one that I'm testing for. Okay, so I solved my case. Okay, so I've solved braceless struct front matter. And I'm going to do struct front matter. So that one is the one that I still don't pass. Somehow we end with open front matter. Why? So when I call parse leaky, we end up in parse struct. Need closing right bracket. The answer is going to be yes. I will need a closing right bracket. I get inside. And I accept only a dot and a right bracket. And when I go here, I will finalize struct. I guess what I want to know now is what is the bad token then? Okay, what's the bad token? I had this printing and then I removed it. Now I want it back, I guess. What's the bad token? I think it was EOF, though. We were getting an EOF. Why are we getting an EOF, though? So this is confusing because I would expect the start parsing to end once we find the closing thing. Why are we at EOF? How did we get to EOF? We should have stopped shorter than that. I'm guessing that there's something else. There's other cases where we might. So it means that we might not be closing this here. We might be closing it somewhere else. Like, oh, you know what? We're probably closing these someplace where we're wondering if we have a trailing comma or not. This also gives me the idea for more tests that we're missing. So let's see if I can have another test fail. So what if it's this? What if it's this? I would expect this to fail. Yeah, it fails. It fails because there's somewhere in the code where we're expecting comma or EOF, and now it's comma, EOF, or front matter. So Bradley says struct, no trailing comma. Let's fix this test. Parse struct. Where's the comma stuff? Where's the comma stuff? There we go. Next, if it's a comma, then we move forward. If it can only be a comma or a right bracket, it can be a comma. It can be a right bracket. Or I guess it can be a front matter. Or an EOF. But I'm saying here that it can be also front matter. But then the expectation is that we wrap up top here. We're checking again. Why was I accepting a right bracket in here? I don't think I did that by mistake. There's some nefarious reason why I'm doing this. Also, am I correctly preventing people from placing front matter tokens when they shouldn't, where they shouldn't? What I'm thinking, there should be something that says self dot, like one front matter or something, front matter meta. I mean, it's inside options, and we just don't accept front matter unless it's one of those cases, just to be safe. Oops, right? Yeah. Yeah, let's look again at the one at the top also. Or we always accept it as a terminal token, but then we complain about it in finalize extract. Maybe. Ah, fuck it. There we go. Now we're filling on line numbers. Expected for phone 5. I should also say probably the dash 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 token to be recognized as a front matter token needs to have like a new line afterwards, maybe some spaces and then a new line. But it's not true. It doesn't need to have. Well, I guess it's either a new line or a new F. So maybe that's what I should do. Like if I recognize a triple dash, then the moment I recognize a triple dash, it's a front matter token. But then to finalize it, I need to eat white space and add a new line. I guess we can worry about this stuff in another moment. So this works. Okay, let's do the line counting stuff, which I don't do super well. So what does fail? Is it lines that fails? Yes, lines fails. That's fair. So here's how it works. So we have the front matter token. I guess we want to then find a new line scalar after that. Hey, Scott. I did take a break during the day. Okay, so the problem if I bake this information inside the token itself, it's bad. It's not really the token. It's not really just a token. It's something more than a token. But I want this stuff to be in... I want the tokenizer to be found matter aware because of that. Okay, let's try this. Line end is going to be std.mem.index of scalar. U8 slice is going to be code starting at talk.end. Talk.lock.end? I don't remember. Yeah, lock.end. What are we looking for? We're looking for a new line. And if it's not, then it's going to be... Well, we're looking for a new line. Actually, wait a second. We don't really want that. So we want to skip white space if there's any. We kind of want to tokenize, but our token is a new line in a sense. It's a new line byte. Maybe that's actually what I should do. I should call for that. I should assert that between here and the new line or the end of... Between here and the end of the line, which can be either EOF or new line, okay, let's do it like this. We set those, but then we refine this count. So there is a new line or there isn't. If there isn't a new line, then what do we want to do? I guess we want to be optimistic and then remove one. So this is line end. We can even do this. Rest of line. Yeah. Index of scalar, new line, blah, blah, blah. This is rest of line. I guess I can just trim some space from it. Also find none. Okay, so if there is this problem, I guess I can return error.open front matter. Hmm. Oh, we still haven't solved this though. We still disagree on the number of lines. It's a bit weird that we disagree on the number of lines though. Why should we disagree on the number of lines? 1, 2, 3, 4. But we found 5. Wait, in which case? This is like braceless struct front matter. No, that's not us. Braceless struct front matter. 1, 2, 3, 4, 5. What's the problem? What is the problem? Hmm. Why is this not working? Doom. We find the front matter, but we disagree on the number of lines. If we were to take this one out of curiosity, would we still disagree? Index out of bounds. Fuck. Index 70. Len 36. Len 36. Index 70. In braceless struct. How the heck did we get there? What? 70, it's a big boy number. How do we get to line end 70? Are we not setting line end? Oh, you know what? We might not be setting line end correctly. We might want to take a look at that, I guess. I mean, No. We definitely do that correctly. We definitely do that correctly in here. So why do we think that something is 70? Talk clock end is 70? What? Okay, let's see. Front matter token, start 32 and 35. Where do you see index 70? What am I missing? Wait, what is Zig smoking? So we have the end token. So this doesn't even need to be parser tokenizer IDX. This can be talk dot lock dot end. Still, $70. Where is that 70 coming from? Is index of scalar returning 70? But we're using the same subslice. Oh no, I think it's the or else. Oh shit, okay. I figure out what it is. It's this. It cannot be code.len. It has to be code.len minus talk.lock.end. There we go. Okay. Front matter failed. What's the problem though? Expected for found 6 in lines. No training comma. I think the problem is I think I tokenized wrong because I need to recognize the triple dashes, but then I need to recognize I need to get myself in some white space. Yep. I need to recognize that there's a white space after. We could be super strict and say there has to be a new line right after, but it's so annoying to annoy people over white space stuff. I'm still kind of unhappy with what I'm doing here. Yeah, this is not enough. Like we need to basically do this, but we're not ready yet. We need we need a different state, and the state needs to be front matter start or something. Either that or we do it like here, where we say, um, hmm, yeah, so if mem contains u8, is there not contains? I guess there is index of. There's like, well, I can do it like this, I guess. Actually, tag doesn't matter. The end doesn't matter. All that matters is state. And then we continue. Is there an invalid state? Am I making this up? Oh. Interesting. So we don't have a dedicated invalid thing, so we have to do it ourselves. Okay. So I guess we return invalid. Yeah, I think I kind of want another state for this at this point. I basically want to detect the triple things, and then I want only white space, a new line, or EOF. And that finds me the token correctly. And we make the token eat all that much space. Who cares? That actually sounds good to me. Okay, let's add another one. Start identifier, name string, comment, start comment, front matter. So we find a triple dash. We increase by 3. We do not do any of these things. We do state equals dot front matter. Otherwise, we think that this thing is a number. Okay, so we're going to state front matter. And we say something like this. Or simplified version, where is it? Yeah, this is probably a good simplified version. Let's see. Front matter. If we see so if we see space, tabs, We see space and tabs in, I guess, carriage returns. I guess we don't care. We consider those white space. Are they actually? Control code VT, control code FF. Well, yeah, it's fine if we don't include those. So spaces are fine. We don't do anything. This finalizes. Everything else, it's invalid. So we say it's a front matter, and it's going to be the index where the new line is. We increase index by 1. That's delightful. Then else, if it's space, we ignore. Else, we complain. How do we do this? Like this, I guess. Yeah. Let's see. Hi, I'm new here. And just wanted to ask if contributing to the Zig language is a good idea for a newbie, or maybe start with other things. The best way of contributing to the Zig language as a newbie is to use the Zig language and use it to do something good. So in a sense, to contribute to the ecosystem, but it doesn't even have to be something where you make something for other Zig users to use. That, not to say that that's bad, that's still good, but like the bar, like to contribute successfully and like in a meaningful way, it's not even that. Just make something good for yourself. That's already enough. And honestly, what I would recommend for a newbie, because if you try to make things for other people to use, to do that well, it requires a lot of competence using Zig. So is it good if I make malware in Zig? I don't know, like, do you need malware? You don't have enough malware, you need some more? But yeah, so making something for yourself is good. Why don't you use cursor? Why don't I use cursor? I don't know. I have a cursor in my editor. Like, it's here. You can see I'm using the cursor to edit the file. By the way, by doing this in the tokenizer, oh, there we go. Bad token invalid. Dot? Where do you see that dot? I meant cursor ID. I know that what you meant. Why should I use it? What's the point? To get AI to fuck up my tokenizer more quickly? Like, I'm doing this finicky stuff that I am confident that the AI would mess up. And like the confusion that the AI would bring into the thing is just not worth it. If I was doing something else, maybe. But like normally I don't need AI integration because what I'm doing is just too finicky. And it would just slow me down. There's not a ton of boilerplate. It's just finicky shit that it's nuanced to get right. Like, I don't think that AI would get this stuff right. I'm not getting it right, so you know what? I'm not judging. I'm just saying. I'm just saying. Yeah. Okay, let's see. Self-IDX plus equals 1. Oh, can we actually do plus equals 1 every single time before breaking? Also, why are we doing plus equals 1 before breaking? Because of the new line. Huh. Let's see. I just did a simplified browser in Zig, still many improvements needed, but it was fun to see some more weird bugs. Cool. I'm trying to create a child process using SED process child to run netstat-v. I want to print the standard out of the child process to my main program. I'm not able to do that. Can you show on stream how to do it, please? I'm really stuck since Friday. Well, so the idea is by default, you should automatically get that behavior because so the way this works in SED process child, you can see that by default, you have this thing called std in behavior, std out behavior, stdr behavior. These are the properties of your child that you want to modify in case that you need different behavior, although the basic ones should do what you mean. So the way it works is that by default, I tried those but no luck. Inherit the stream from the parent process, ignore, pipe, and close. So normally you want to keep inherit. You can understand by only running netstat-v in another session. So here's a second question for you. Do you wait your child? After spawning it, do you wait for it? Because the problem is that, okay, so you wait for it. But it stays open. So how do you're not really waiting for it, right? You have to close it at some point. So how do you close it? How can I do it in real time? You need this. You need pipe. You need to have the behavior be pipe. And then you need in your program, while the child runs and you're not waiting it, so without waiting for it, then you need to consume these guys. Well, you need to consume, I guess what you care about, I'm guessing, is standard error or standard out, one of these two guys. So you need to consume these guys. Let's see, the reading end of the child process standard output pipe. Usage requires std out behavior to be pipe, available after calling spawn. So you init your child, you spawn your child. After spawning the child, you don't wait for it, and instead you start reading from this guy or this guy, depending what's appropriate. And then you do what's necessary, which is print it out or do something else. It only prints output of netstat-v directly. I agree with you. I want to consume bytes from stdr to stdr. And I don't understand what your complaint is here, but it only prints output of netstat-v directly. So what do you want? I mean, that's what you want, right? You want to read this file. By the way, you don't necessarily have to print what you read from here. You can read and save in an array list, for example. You can try to parse it even. I don't know if parsing netstat-output is the right move, so that is something that you'll have to figure out by yourself. But if it is the right move, then that's how you do it. Yeah, and so it's up to you to decide what to do with it. You can even spawn a separate thread, by the way, for pumping stuff. Yeah. So the way it works is that you read this guy inside of an array list, or when you call read on it, on this thing you do like read. For example, you can do like read the line, read until the limiter or UF, that kind of stuff. So you can read that, buffer it in an array list or whatever you want, and then decide what to do with it. So that's what you want then. Pipe behavior, and then you decide how to read this file and where to put it and why, etc. Okay, so since we're doing that fancy stuff, we don't need this anymore. But now we have a failing test. I'm unable to do it. Can you show it? Sorry if it's too much to ask. It's not too much, but here's what I would counter ask you. Try doing it, see how far you get, and then put your code in zigbin.io. Share with me your program. I will take a look, point out obvious wrong things that I see right away. If I don't see anything obviously wrong, I will try to run it myself, and then I will modify it and make it work. I'm not going to say live for long today, so you might want to, I don't know, maybe wait for the next stream. But in any case, it doesn't have to be today. Whenever it is, feel free to do that. Like whenever you're ready, share with me a snippet. I'll take a look. And I'll help you make a little bit of progress based on where you are. So our tests failed, and they failed because we got an invalid token, because we say bad token invalid. Why do we think it's invalid? I think we're doing some math wrong. You know why? Because we probably want to increase by 2, not by 3. Because we actually consume 2 extra bytes. And then the next one is going to be the new line. Bad token invalid. How is that invalid? Come on, dude. That's okay. That's great. Okay, so I think we're like somewhat getting better. It's still not right, but we're getting better. So this is correct. Okay, we get into front matter. Space tab, carriage return, we ignore. And the new line, we set and break. Do we want to include this thing? No, we don't. Also, you know what? I don't think we should set the location end in this case, or should we? You know what? No, let's do that as well. But this is invalid. But why are we getting, what the heck are we getting here? Here's your code. Let's see. Span child, here pipe, buff undefined, std out. Where's std out? Oh, here, right? Yes. Reader, while true, read all. It doesn't print anything. Are you sure that this guy? Are you sure that netstat is printing to std out? It is printing to std out when you invoke it directly. Okay, I think that what you want to investigate next... Wait, do I still have it open? No. Okay, here's what you want to investigate next. What if I do this? netstat pipe echo. Doesn't print anything. Is it because echo? Uh, okay, that doesn't work. I assume that echo could accept pipes, but I guess it doesn't. Wait, can you pipe into cat? Oh, you can pipe into cat. Okay, so if I pipe into cat, what do I see? So you see that piping netstat into cat also doesn't print anything, which I find interesting. And I wonder why. So it might be that it has different behavior based on whether you're invoking it directly in the shell or if you're invoking it into something else. It's not strictly necessarily special about netstat, but yeah, it's basically checking in which environment it's being opened, and like it's able to tell if it's being loaded in a terminal or not. And it makes sense for it to, not want to, want to behave differently depending on where you invoke it. So here's what I recommend you do next. Check out these other flags that netstat supports. Then the second thing that you can do is this. So we were looking at child here. There's a TDY thing, right? Somewhere. Where is it? Oh no, there isn't. Wait. You can fake being a TDY if you're not if you're piping. How does that stuff work? I'm actually not sure. I've never done it myself. Can you really not fake it? There has to be a way of faking it. So I think the netstat might just be hostile to what you're trying to do. I don't know. Let me copy this code, download. STR behavior pipe. Let's not do that. Let's just do std out. Okay, let me try not modifying anything, spawning, and then waiting. Oh, right, because it's CMD. What am I doing? Wait, you're returning. You're expecting a waiting return. Oh, there's no thing. CMD. Okay. Let's see. Error union is ignored. Try. Oh, I guess it's because for you it was previously something else. So we are getting the output. So with this, we get the output. But with a pipe, we don't. Log info. Let's do std debug for print. Yeah, you don't see anything. Okay, the problem is that netcat doesn't like being piped, which is what you are observing also here. Like even this doesn't print anything. So I don't know. It's just the netcat hates you. Long story short, if you want to do this, you will need to probably find a different way. Look at the flags the netcat has. There might be a flag that makes it like not do this whenever, like that makes it work also when it's being piped, or you need to use something else, like some function in the C standard library. Who knows? So you need a different route for doing what you are trying to do. Okay, I want to see my bad FM char now. No problem. Where's my... It says invalid. Bad token invalid. We don't even get in here? Oh no, I get what it is. We're getting the end. And if we're in front matter... Let's not do anything out of curiosity. Is this it? No, it's still invalid. Oh man. Okay, I need to figure this one out. So here's what I'm gonna do. I'm gonna call it a day, I think. I'm gonna stop streaming. I need to have dinner. Then I need to do the stream with Abner. So if anybody's interested, I will be on Abner's stream later today, if everything works out. And yeah, I'll see you there. So thank you all. And I'll figure out this stupid tokenizer thing. Once we're done with this stupid tokenizer thing, I think that we're gonna be in better shape. This is gonna make Zine way less jankier. And unfortunately, it feels like that Ziggy of all parts. So okay, let's not be too negative. There's one nice thing that's happening. As the project level of overall quality grows, then you have certain pieces that becomes the worst part of the system. While before, when everything else was worse, they weren't all that bad. They were either in line or maybe even better. I think there was a point in time where Ziggy was pretty good. But now everything else has improved so much that now Ziggy freaking sucks compared to everything else. So we definitely need to, at some point, circle back and do a big polish pass to Ziggy, like top to bottom. I don't want to do it now. For example, here's just another one. Make the tokenizer leverage the new label switch syntax, which also has a performance improvement. So we totally want to do that. But for now, I just want to basically have the improvement just be integrate better with front matter parsing. That's already an improvement. It's not the end goal, but we made an incremental improvement towards a better solution, because the final solution, like the perfectly structured Ziggy, will probably have a tokenizer that understands front matter delimiters, so that it can give us an efficient way of counting line numbers and all that kind of stuff. So I'll figure out what the heck I'm doing wrong at some point later today. So thank you all, and I think I'll see you. Let me see if anybody is streaming. But I don't see anybody doing Zig streaming. So I'm just gonna call it a day. And as I said, if you're gonna be still around in, I don't know, a couple of hours, I'm gonna be on Abner's stream.